All right, good morning this morning. Welcome to another episode of Breakfast with Data. This is our deep dive with data series. It's raining heavily in Lagos this morning. I don't know if it's raining where you are. Please grab a beverage of your choice or whatever your breakfast beverage is, and let's dive in. Um, Okay, today we are going to be looking at joins in DataFrame. How do you join multiple data frame? Yesterday we were looking at how do you do aggregations in DataFrame with Pandas and in PySpark. Things like when you want to have some summary statistics, like mean, the maximum, and do count and stuff like that, and we saw what that looks like in a in data frames. I mean, what gives data a lot of the sense is the ability to do the joinings, to merge this data set with some other data, and that will help you to make better sense of that data, because that's the whole essence of relational databases and a lot of structured data, is the fact that you can join them to another data. But there is the trap, right? If you are doing joining, you have to be very careful what kind of joins you are doing, and that you are not mistakenly leaving certain data sets out when that is not the plan. Without further ado, let's jump into the subject of today and see where we are and where we need to be. So, in fact, before we even start, maybe there is someone that is new to join completely. There are different kinds of join, right? There is the full outer join. There is the join can be inner or outer, right? And I mean things like cross join also. So inner join can be left or right, right? So you can have uh um so if we say, suppose we have two data sets, right? And this is more like the real set actually. And we have, let's see, data sets A and data sets B, right? When we are trying to do join, an inner join, we look at, let's take this, Control C, Control V, and inner join will be this point of intersection between the two, right? So suppose we have this as blue and we have this as uh, orange as well. In fact, this maybe blue and orange may not be the best. We should just do yes. So suppose we have this, and let's do this as well, right? Or let me change this to maybe to make a lot of sense like this. So this point of intersection in between the two, where we have this green blue, that is inner join, right? So if I can write I inner, this is what we mean when we say inner join. This is the inner, right? And this will be L left, and this will be right. So when you are dealing with inner join, you are looking at what you can find on the two both, right? And if it is left join, you are thinking of everything in this one plus only matching rows in the right, right? If you are looking at the right, you are looking at everything in the right plus matching rows in the left alone. Now, right and left join are actually they are symmetry. Um, they are symmetry of each other. It's like a symmetrical stuff. Now there is full outer join, which is everything, right? The outer join, all rows, both. So in this case, when we do left or right, any row that does not have match in the other one will replace the values there with null. That's how it works. Now, join. There is also cross join, which we rarely use in real life. Cross join, yes, every row from the left with every row from the right, and it looks at every possibility, right? Every possible join, every possible ways they can be joined together. But I know that mostly we all know what these are, and um let's just dive a little bit deeper. Now, import, let's import multiple. Listen, let me open our data catalog. Just a minute. Let me open our data catalog here. Excuse me. So that we can see the different data sets that we have. And we are going to bring in a couple of data sets so that we are able to do that. So what I'm going to do, I'm first going to import pandas as PD. Let me close this. Let me know if you can see my screen, if it's bold enough as PD. And then I can bring in students. And I will set it to be equal to PD dot read CSV. And I'll go here. I think, yes, we do have Greenfield students. I'll just copy this path and we'll paste this. I can also do enrollments. Set it to PD dot read underscore CSV. And I can go pick our enrollment path. Just copy this and paste it in. And I can also do let's do one more so that we can see something. Okay, let's pick courses. So I'm going to pick this and I'm going here. Yes, courses, and I will set it to be equal to PD dot read CSV, and we can paste it here and run it. Now let's quickly inspect our different data frames. I can do students. Go ahead, Mafi. What's the question?
Okay, sir. Sorry, I don't want to stop you earlier. The difference between union and full outer join now, is it because is it that union now they must always have the same schema like column structure and full
Union,
outer join does not need that or there's
yeah.
two more
So
things?
so in a union, right? You are merging based on the columns. So the rows is like you are appending at the end of it. Is that clear? But with join, you are merging two tables. Union should increase the row, join may increase the column. Does that help?
Okay, that means the full outer join because it always has a criteria that you are joining on. But union does not have a criteria like joining on. It's just
Yes. So union needs to have like identical column names. Join only needs the key columns to match. In fact, the name of the key columns may not even be the same thing. You understand? So you might have student ID on one table, but it's linking to ID on another table. So it might be ID on the primary key table, which is the maybe student table might be ID, or on the what is it called table, on the table where is the foreign key. You understand? It might be student ID. So you can link the two together based on that. But union, everything must match, because union, you are looking at two identical tables, and most of the time you use it as maybe you are joining for backup. You now want to, you've splitted these different tables into, you've partitioned them differently, then you need to bring them back again.
yes, that's clear. Thank you, sir.
You're welcome. Okay, let's see students dot let's say add, and I can just display these guys. And I can copy the same thing and do for enrollment. And this is taking forever, so let's reload. I hope the rain has not affected this day, and we can have these courses, right? And we can run this now. So we can see that okay, this is even a beautiful one. So on the student table, student is the primary key. On the enrollment table, in fact, the enrollment table is the bridge table here. So we have the enrollment ID as the primary key, but then we have student ID as a foreign key, and the course code as another foreign key here. So we have the primary key here for course code. If we want to do let's say we want to do a result table, right? So we can say result is equal to student dot merge. That's how you do join in Pandas. Merge, and we can merge enrollments is students. So that data frame, we want to merge enrollment to it. So this is like you say join, and we'll say on what is the column. Now by default this will be a, and you can see that this column is equal to the same, we have student ID, this, so we can bring in student ID because they have the same column name on both table. So we can run this like this, and we can display the results. And when you take a look at this is an inner join, right? It will only match to the tables that have matching where there is a match, right? So any
Mr. Please go up. I want to see the inner join. Sure, thank you.
Okay. Now, suppose you want to do a left join. How do we do that? We can rewrite this same query, and instead of just saying stopping at on, right? We can add another parameter here and say how. Do you get? We can put how here and set it to be equal to left. Of course, you can put right, you can put right, you can put left, you can put anything. Do you get? So let's run this now. And if we were to run this is now a left join. You might now be asking, we are using on, and I said earlier that in some cases the tables may not have the same key. I mean, the keys may not be the same name, they may not be named the same thing. This particular case is named ID. Let's say on the student table is named ID, not student ID, and it's on the other table that is that. So what you can do, left on, right? Left on, right? So this will take, this student is the left, right? And the right is enrollment. So left, right. So you can say left on student ID and right on, excuse me. You can say right on we just do, excuse me. John, your hand is up.
So I missed that place where you were saying if it's on the other table when you change it to left on. What condition is making us put it there? I did not get that place.
So suppose that in this particular case now, we really don't have a case for it. You can use on, just a single on, because the name does match. You understand? It's like when you are writing SQL and you use using instead of using your regular on, something is equal to something. So when the column names for the primary key and the foreign key match on both tables, when they bear the same name, you can use on. But when the name differs, or when you want to be explicitly sure that you are picking the exact column name, you can do left on. So this left on will come from the column in the student table, or whatever is the table on the left, and the right table will be the right on. Do you get that, John?
Yes, Mr. La, one more question before you leave.
Go ahead.
I've always used join. Quite all right. But there's one question I want to understand is, what determines the table that will be on the right, and what determines the table that will be on the left?
The way you write it, right?
Okay, for instance, now, let's say I have like this student and this enrollment. If I put enrollment on the left and I put student on the right, I will still get a result, right?
Yes.
Now, what condition will make me know that, okay, student that must be on the left for this thing I want to write, I'm already on the enter, and this thing must be on the right?
Okay, it depends on what you are trying to achieve, right? If I want everything from student and matching rows from enrollment, for example, I want every student, right, to match, to have their enrollments matched. You understand? I will do this. Do you get? I would put this on the left and put this on the right. So I have enrollment for every one of these students. You can see this in this particular case that I'm having enrollment, and this is a classic case. What should have actually happened? What would have made this make a lot of sense? Because you can see that we are seeing repetition of student ID. In fact, this result, you get result per subject that you enrolled for, right? So student 101 got this. So it depends on what you want to do. You should also remember that right and left, they are symmetrical, right? If I change this to right now, right, enrollment becomes the one, every row from enrollment and matching rows from students. Does that make sense?
Yes, sir. Yes, sir.
So again, it's up to you how you arrange it and what you intend to see. So another thing we can do, in fact, let me just copy this and use this, because there is another way to write this. Let's just do on instead of left on, right on. Let's just do on student, and we can even make this a little bit neater. You can write this like this, so that if you like to see them this way, there is a hidden trick that you can also do. There is another this thing. You can add indicator equals true. If I run this and I say display results dot sample, let's say 10, right? And we can now see this new column that came with it, right? So this indicator is showing that this row is based on the both of them, right? Because we are doing left join, but it's telling me where the different rows are coming from. But what I can do to even know if I can do a value count, you can say results dot because it will show right only, left only, result dot I think I can pick this column, this merge, and this merge appear because I put this indicator equals true. merge column, it will tell me where these rows are coming from. I can now do dot value and count, and if I run this now, okay, you see that all of them actually match. You understand? We don't have one column in one table that does not. So you will see in this particular case, left only, right only. Of course, we are doing a left join, so we won't get left only and right only. In fact, if we now do outer, let's try and do full outer self and see what this will bring for us. It's still the same thing because this table is just it's almost perfect. So we have both. Yeah. Any questions so far?
So actually, I missed this place. What are we trying to do here? This result meant to value count.
Just so that we know where the result is coming from. Which
What
table?
result of may I ask, please?
So we introduced this indicator, right? Yeah. And this indicator, we add another column here. And this column will tell us the source of this particular row, right? So it's telling us that both of them match on this because we are matching on student ID. So student ID 006 exists on both tables. If it exists on only one table, let's say it exists only on the student table, it will pick left only, right? Excuse me. It will pick left only. If it exists only on the enrollment table, it will show right only here. And if it exists on both tables, it will show both. Now, what I did here was to try and see if there are, we just took a sample of 10, right? And I wanted to see if there are any tables. So I'm doing a distance count on their distance, and I use this value count method, right? So this is more like count group by. So 202 is both. So both is the only value that is here. So left only 0, right only 0. Does that make sense?
Yes.
Good. Now, what was I about to do? Now you can see that there is something that has also happened here, and this way, if you are doing this thing, this might throw error, especially maybe you want to use it to create a table and stuff like that. You have student ID here, and student ID appear on both table. If you are writing SQL, I tell you student ID is ambiguous, right? If you are fetching that same student ID, how do we know which student ID we are dealing with? You can also introduce something called suffix. Let's say I'm even doing result and enrollment. Let's say let's do courses. Let me even do another one. Let's say result, and I can do enrollment dot merge. All right, I can merge enrollment to course on course code, right? Courses, comma, on. I said this equal to course code, and we can do this will be an inner join, right? So I can do suffix and have the suffixes set it equal to enrollment. That will be for the right. So I can do underscore and enrollment, right? Underscore courses. Okay, so if I run this now and I display results, dot sample, let's sample 20 out of this. You can see that now enrollment ID is not even showing. Did I write this properly? Because since this both of the tables have, in fact, let me change this. Maybe let me change this to maybe still picking the old this thing. Results, display results. Both table does have status, right? Oh, courses does not have. So it's just there is nothing that is the same on the two both of them. Okay, and the joint tables will definitely match, but assuming the two of them have some columns that have the same name, you will have the suffix of each one. I don't think I have a data set that we have the same. So suppose we have status on course and we have status on enrollment. We have the two as matching. We have the suffix on the two both of them. Okay, let's continue. Let's try and do this in PySpark. If we want to do the same same stuff in PySpark, of course I'll bring in our column, and let's say I'll bring in our maybe I will do a broadcast join. So let's do from PySpark .sql .functions import col, and I mean import broadcast as well. Broadcast, right? And I can bring in Spark students, Spark students, and set them to Spark dot read dot csv. I can have I'll copy that one shortly, and I can set header, or I will set header is equal to true, and also set in fast schema set it equal to true as well. Now we can also bring in the other one, which will be Spark enrollments. And I can set this to Spark dot read. In fact, I can just copy this guy. So I will change just the URL. Good. Now I'll just go and copy student URL. and I'm going to copy the enrollment URL. I'll just leave this one as it is. Good. So I can run this now, and we have this. So how do we do results here? So we can do results, set it equal to Spark student dot join, right? And you put in the Spark enrollments, and we tell it how we want to join it on equal student ID and we can have um, we can have what is it called? Gonna have this how. Or if we run this like this now by default, Timmy, your mic is on. Do you want to ask a question? Okay. So if we run this, we still get the same thing. If we do display results, display now display. Now this is the inner join, right? We can tell the kind of join we want also here. Can switch this to left. Of course, you can do right, you can do you can leave it as inner, you can do full outer, but for most of the time, left is always the right. Right join, which is kind of funny, right? Left join is mostly the right join to use. So if you are ever guessing. Now, one thing that we can do is, suppose we can also write this. Remember the other time when we were doing left on, right on? We can write this in a different way. Then maybe we'll just we'll just do this now, and let's make this even neater to read so that we have this join. See, when we're doing left on, right on, we could actually use the dot notation, right? So we can do the condition. Instead of adding on here, I can just do Spark student dot student ID. This is another reason why we should always use underscore, no spacing in your this thing, because this would have thrown some errors. Now, then we can do the Spark enrollments. Doesn't really matter the placement here. Dot student ID. Let's run this and see if we get any error. We did not, so we spelled that result is equal to results dot show 10, and we'll get the data frame kind of stuff. Now remember that we are working in Spark here, right? And because of this, we have to be very, very careful how we do some things, right? When we are doing join can be crazy if we don't plan join very well. It can make your Spark this, because you have this in different clusters, different we have it in different partitions, right? The table is clustered on different nodes running, right? If you have a very small table, you can broadcast that table across the different node. So suppose we have courses table seems to be the smallest table in this. Our course is very, very small, so we can broadcast that. Let's bring in Spark courses. So I'm going to copy this. I'm just going to say Spark courses. Spark courses. And I'm going to set it equals to spark dot read dot csv, and I'm going to pass in the URL that I just copied. I'm going to say header is equal to true, right? And infer schema, I'm going to set that one equal to true as well, right? And I'm going to run this now. Now, suppose I want to join enrollment to courses. Now, enrollment may be, let's look at a university, right? University might have 10,000, 20,000 students, right? And each of those students enrolling in different courses. So you might have, maybe per student, you have 10 courses. That's like 1 million, right? For, total number of enrollment. And if you now want to look at per semester, per session, if you are looking at every enrollment in every single session, that table can easily grow. But you might have only 200 courses total that the school is offering in different departments, right? So that is a case here you can do your broadcast. So suppose we want result to be equal to let's say Spark enrollments. We can do dot join and we can do broadcast. Broadcast Spark courses. So what this will do, it will put Spark courses on every executor, and that avoids shuffling the big table. That's the Spark enrollment. Broadcast. Did I spell broadcast very well? Broadcast. I brought this in. Yes. Broad. broadcast. Because it's really showing. Yeah. Okay. Broadcast. And I can say on equal to course code. Then we can do result. This will make your join result dot let's just display results. Now, because both are small tables for the purpose of this tutorial, you may not notice the difference at all, right? You may not even see anything. But when you are dealing with big data and a small maybe lookup table that needs to join to most of these, you should use broadcast. When should you use broadcast? How do you know when you should use it? The rule of thumb is that if your right table, the smaller table, the table you want to join, that you want to broadcast, which is the right table in this particular case, because Spark enrollment is the left table, this is the right table. So your left comes first, right, because we read from left to right in the Latin, this thing that we are following, right? You have to, if it's about maybe less than maybe it's 10 rows, less than 10 MB, just broadcast it, right? Because shuffle can take, if you are doing a real pipeline and you are shuffling a big table, that can take up to depending on how big your table is, maybe 30 minutes, and you are doing join. So again, it's one of those things you look for when you are dealing with big data and maybe the pipeline is slow. It's one area you come and look at. How are you doing joins on the cluster? That being said, I don't know if there are any questions so far.
Sir, the broadcast is not going to be efficient if both tables are large.
Yeah, it doesn't, it's not efficient if it doesn't make sense.
Is there like a bandwidth to know large tables? I don't know.
So what I'm saying is that you should have like 10, you should have, if you have like 10 MB or under,
okay.
That's fine.
I think
That's fine. So because the whole idea of this broadcast is that it's going to copy the whole table. It's just like you have it on every executor. Everything is like how do I explain it? I have not even taught you guys what is it called?
Is it like it hold it in memory and then spread it?
I would have said memory, but data frames are entirely in memory before. You understand? Spark is running in memory. But because, take it this way, is that that Spark runs on its distributed systems. So all of this data frame is distributed across, maybe you have 10 nodes, right? And the data set, it depends on, it's the one that decides how it puts the data set. What you are saying is that this small table, just put it in the executor, broadcast it across everybody, right?
Okay, I understand now.
So every executor for every of the nodes, this thing will put it there. in the Spark engine, we put that small table. That's why it's very important that it's a very small table. So what we qualify for a small table: state and capital. You understand? State code, gender, um, maybe dim season, semester. You understand? And you need to use all these ones for join. You can always put them in this table. Once they are getting, it's a very big table. For example, student table. Don't put that one. Don't broadcast the student table. You might end up not not enjoying the whole benefit. What you are trying to even get, you might miss. So let's look at certain things that you must also check. You understand? Before you do any join. For each row on the left, how many matching row are you expecting? So you must do a cardinality check. You understand? So that it will not confuse you in this way. For example, now, if you look at this, our you can see some stuffs here now, many to many. You understand? But you need to know that this is where your this thing should be coming from, right? Your primary column should be enrollment ID, because enrollment already has many, right? Unlike ID. So you need to also have a way to check the two both of that. So cardinality 1 to 1. So 0 or 1. Those stuffs are things that you need to check in the table, and we don't have the time to check it. There is a Pandas method for I think there is a way we can validate if it is one to many, if it is 1 to 1, many to many. Many to many is the one you want to avoid most of the time, because that can create a lot of problem. 1 to many, many to 1 is fine, because 1 to many and many to 1 is just a symmetry. You just need to reverse the table if you want to see this first. You can see enrollment to student ID. You can see that many one student ID can have many different enrollments. So that's a 1 to many, right? And that will increase the number of rows that you are seeing. So again, it's something that is very, very important that you check and make sure your cardinality is right. Because if you don't do that, if you don't check the cardinality of your joins, you might be making a big mistake. You might overinflate. And sometimes we will see that when we do joins, we just end up with more rows than we are expecting. It's because maybe you have done a many to many relationship. And I used to tell people, maybe we'll take a class later on uh, on data modeling. You understand? And you have to be very careful too when you are using the kind of inner, outer, left or right. Know what you are picking and what you are missing. Once you have all of those, I think you'll be fine. Any question? Yeah, I think about 55 minutes in. Okay. In the absence of questions, thank you very much. It's been Breakfast with Data. Do have a lovely day ahead. Thank you.
Thank you, sir.